According to the National Electrical Code, specifically Article 250.122a, an unfused load wire extending from a meter base to a panel board must not exceed 6 feet in length. This requirement exists for several crucial reasons related to electrical safety and performance. Unfused load wires are those that carry electrical current from the meter base, which is typically located outside a building, to the main panel inside the building. The main panel is where circuit breakers or fuses are installed to provide overcurrent protection for individual circuits within the building. Because these load wires are unfused, meaning they lack overcurrent protection until they reach the main panel, limiting their length is a critical safety measure. The primary reason for limiting the length of unfused load wires to 6 feet is to minimize the risk of damage or overloading. Longer wires are inherently more susceptible to physical damage, such as cuts, abrasions, or punctures, which can compromise the insulation and create a short circuit or ground fault. In the event of such damage, an unfused wire can carry a very high current, leading to overheating and potentially a fire. By keeping the length short, the probability of physical damage is significantly reduced. Another important reason for limiting the length of unfused load wires is to mitigate the effects of voltage drop. Voltage drop refers to the reduction in voltage along the length of a conductor due to its resistance. Longer wires have higher resistance, which results in a greater voltage drop. Excessive voltage drop can negatively impact the performance of electrical appliances and equipment, causing them to operate inefficiently or even malfunction. In some cases, it can also lead to overheating of the wiring and connected devices. By restricting the length of unfused load wires, the code helps to ensure that voltage drop remains within acceptable limits. Furthermore, unfused wires pose a significant fire hazard if they come into contact with other conductors or grounded surfaces. If an unfused wire is accidentally shorted to ground or to another conductor, it can draw a large amount of current, leading to rapid heating and potentially a fire. This risk is particularly acute when the wires are not adequately protected by overcurrent devices. The 6-foot length limitation helps to minimize the amount of exposed unfused wire, thereby reducing the likelihood of such hazardous contact. It's also important to note that the National Electrical Code serves as a baseline for electrical safety standards, but local jurisdictions may have their own amendments or interpretations of the code. In some cases, local codes may impose stricter requirements or provide additional clarification on the length of unfused load wires. Therefore, it is always essential to consult with the local electrical inspector or authority having jurisdiction, also known as the AHA, to determine the specific regulations in your area. These local authorities can provide guidance on the applicable codes and any local amendments that may be in effect. When installing or working with unfused load wires, it is crucial to adhere to all applicable code requirements and safety guidelines. This includes using the correct wire size, ensuring proper insulation, and providing adequate physical protection for the wires. In addition, it is important to carefully inspect the wiring for any signs of damage or deterioration and to address any issues promptly. Neglecting these precautions can significantly increase the risk of electrical hazards. The 6-foot limitation on unfused load wires applies specifically to the distance between the meter base and the main panel. It does not apply to other types of wiring or to fuse circuits. For example, branch circuits that are protected by circuit breakers or fuses can generally be longer than 6 feet, provided that they are properly sized and installed in accordance with the code. It is also important to distinguish between the load side and the line side of the main panel. The load side refers to the circuits that supply power to individual appliances and equipment, while the line side refers to the connection to the utility power grid. The 6-foot limitation applies only to the unfused wires on the line side of the main panel, between the meter base and the panel. Once the power passes through the main breaker or fuses, it is considered to be on the load side and is subject to different code requirements. In summary, the 6-foot length limitation for unfused load wires extending from a meter base to a main panel is a critical safety measure designed to prevent electrical hazards such as damage, overloading, voltage drop, and fire. By adhering to this requirement and consulting with local electrical inspectors, you can help ensure the safety and reliability of your electrical system. Remember that electrical codes and regulations are subject to change, so it is always important to stay up to date with the latest requirements. The National Electrical Code is typically updated every 3 years, and local jurisdictions may also issue amendments or interpretations on a regular basis. By staying informed and following best practices, you can help to protect yourself, your property, and others from the dangers of electricity. When working with electrical wiring, it is always advisable to consult with a qualified electrician. A licensed electrician has the knowledge, skills, and experience to perform electrical work safely and in compliance with all applicable codes and regulations. Attempting to perform electrical work without proper training can be dangerous and may result in serious injury or property damage. Furthermore, improper electrical work can create hidden hazards that may not be immediately apparent but can pose a risk of fire or electric shock in the future. Therefore, it is always best to leave electrical work to the professionals. A qualified electrician can assess your electrical needs, design a safe and efficient electrical system, and perform the necessary installations and repairs in accordance with the code. They can also provide valuable advice on energy conservation and electrical safety. In addition to the 6-foot length limitation, the National Electrical Code also specifies requirements for the size and type of conductors used for unfused load wires. The size of the conductor must be adequate to carry the anticipated load current without overheating. The code provides tables and formulas for determining the appropriate conductor size based on the ampacity of the circuit and the type of insulation used. The type of conductor must also be suitable for the environment in which it is installed. For example, conductors installed outdoors must be rated for wet locations and sunlight resistance. The National Electrical Code also addresses the issue of grounding and bonding. Grounding is the process of connecting electrical equipment and wiring to the earth, which provides a path for fault current to flow back to the source. Bonding is the process of connecting different metal parts of the electrical system together to create a low impedance path for fault current. Proper grounding and bonding are essential for preventing electric shock and ensuring the safety of the electrical system. The code specifies detailed requirements for grounding and bonding, including the size and type of grounding conductors, the methods of making connections, and the location of grounding electrodes. Failure to comply with these requirements can significantly increase the risk of electrical hazards. In addition to the technical requirements of the National Electrical Code, it is also important to follow good work practices when installing or working with electrical wiring. This includes energizing circuits before working on them, using appropriate personal protective equipment such as gloves and eye protection, and carefully inspecting the wiring for any signs of damage or deterioration. It is also important to avoid overloading circuits, which can lead to overheating and potentially a fire. If you are unsure about any aspect of electrical work, it is always best to consult with a qualified electrician. Another important consideration is the proper labeling and identification of electrical circuits and equipment. All circuit breakers and fuses should be clearly labeled to indicate the circuits they protect. This makes it easier to identify and isolate circuits for maintenance or troubleshooting purposes. It is also important to label electrical panels and disconnects with their voltage and amperage ratings. Proper labeling can help prevent accidental overloads and ensure the safety of electrical workers. The National Electrical Code also includes requirements for arc fault circuit interrupters, known as SIs, and ground fault circuit interrupters, known as GFCIs. SIs are designed to protect against arc faults, which are dangerous electrical arcs that can occur in damaged or deteriorated wiring. GFCIs are designed to protect against ground faults, which are electrical faults that can occur when current leaks to ground. Both SIs and GFCIs can help prevent electric shock and fire. The code specifies where SIs and GFCIs are required, such as in bedrooms, bathrooms, and kitchens. In addition to the requirements for unfused load wires, the National Electrical Code also addresses the installation of service entrance conductors. Service entrance conductors are the wires that connect the utility power grid to the building's electrical system. The code specifies requirements for the size, type, and installation of service entrance conductors, as well as for the location and type of service disconnect. The service disconnect is the main switch or circuit breaker that can be used to disconnect the entire building from the utility power grid. The code also includes requirements for surge protection. Surge protection devices are designed to protect electrical equipment from voltage surges, which are sudden spikes in voltage that can damage sensitive electronic devices. Surge protection devices are typically installed at the service entrance and at individual branch circuits. The National Electrical Code also addresses the issue of energy efficiency. The code includes requirements for energy-efficient lighting appliances and HVAC systems. By complying with these requirements, you can reduce your energy consumption and save money on your utility bills. In addition to the National Electrical Code, there are also other standards and guidelines that may be applicable to electrical installations. These include standards from organizations such as the National Fire Protection Association, the Institute of Electrical and Electronics Engineers, and Underwriters Laboratories. These standards provide additional guidance on electrical safety and performance. In conclusion, the 6-foot length limitation for unfused load wires extending from a meter base to a main panel is a critical safety measure designed to prevent electrical hazards such as damage, overloading, voltage drop, and fire. By adhering to this requirement and consulting with local electrical inspectors, you can help ensure the safety and reliability of your electrical system. Remember that electrical codes and regulations are subject to change, so it is always important to stay up to date with the latest requirements. And when working with electrical wiring, it is always advisable to consult with a qualified electrician. Furthermore, always consult your local electrical inspector's interpretations and amendments of the NEC. The electrical safety is not a place to be cutting corners.